What if the universe around you is quietly disappearing faster than you can imagine? Galaxies are vanishing beyond our sight, forever. If this endless expansion never stops, everything we know could fade into the coldest, loneliest silence. The universe's expansion began with the Big Bang, and has been accelerating ever since, driven by dark energy. In this ever-expanding cosmos, the future holds a universe where stars fade, and galaxies drift apart. Since the Big Bang 13.8 billion years ago, the universe has been growing. This monumental event marked the birth of everything we know, from the smallest particles to the largest galaxies. The universe started as an incredibly hot and dense point, and in a fraction of a second it began to expand at an unimaginable rate. Over billions of years this expansion has continued, with galaxies drifting apart from each other. But now, the expansion is speeding up, driven by a mysterious force called dark energy. This acceleration was a surprising discovery that challenged our previous understanding of the cosmos. Imagine it like an invisible hand, gently but relentlessly stretching the fabric of space, getting stronger every moment. This force is not just a minor player, it's a dominant factor in the universe's expansion. The more the universe expands, the more powerful dark energy becomes, pushing galaxies further and further apart. Did you know? Dark energy makes up about 70% of everything in the universe. This means that most of the universe is composed of this enigmatic force, with dark matter and ordinary matter making up the rest. It's a humbling realization that what we see and touch is only a small fraction of the total cosmic makeup. Discovered in the late 1990s, dark energy was a groundbreaking revelation that changed our understanding of the cosmos. Astronomers using powerful telescopes and observatories noticed that distant supernovae were dimmer than expected, leading to the conclusion that the universe's expansion was accelerating. Its effects are profound, suggesting that the universe will continue to expand indefinitely, becoming colder and emptier over time. As galaxies move further apart, stars will burn out and the cosmos will enter a dark, desolate era. This future scenario, driven by dark energy, paints a picture of a universe that is ever-changing and full of mysteries yet to be uncovered. As space stretches, galaxies drift farther away. So far, their light will never reach us again. Every second, the universe we can observe shrinks. In the distant future, Earth could be trapped in darkness, alone in a vast cosmic desert. This cosmic isolation means that future civilizations might never know about the universe beyond their galaxy. The knowledge of other galaxies, stars, and cosmic events will fade into myth. Our understanding of the cosmos will be limited to our local group of galaxies. The vastness of space will become an unreachable mystery. Stars will burn out one by one, their brilliant light slowly dimming until they are no more than faint whispers in the vast expanse of space. These celestial bodies, which have illuminated the cosmos for billions of years, will eventually exhaust their nuclear fuel. As they do, they will transition through various stages, from red giants to white dwarfs, and finally to cold, dark remnants, until the night sky is pitch black. Imagine looking up and seeing nothing but an endless void, devoid of the twinkling stars that once filled the heavens. The universe, once teeming with light and energy, will become a desolate and empty place. Black holes will fade away. These enigmatic objects, which currently dominate the centers of galaxies, will slowly lose their mass through a process known as Hawking radiation. Over an incomprehensible span of time, they will evaporate completely, leaving behind nothing but a faint trace of their existence. New stars will stop forming. The raw materials needed for star formation, hydrogen and helium, will become increasingly scarce. Without these elements, the birthplaces of stars, known as nebulae, will cease to exist. The universe will no longer have the ability to create new sources of light and heat. Eventually, even atoms, the building blocks of everything, will break down. Protons, neutrons, and electrons will decay into simpler particles, leading to the disintegration of all matter. This process, known as proton decay, is a theoretical prediction that suggests even the most stable particles are not eternal. This means the very matter that makes up you and me will slowly unravel. The molecules that form our bodies, the structures that define our world, and the elements that constitute the universe will all disintegrate into a sea of subatomic particles. The universe will become a silent, frozen void where time still ticks, but nothing ever happens. In this final state, known as the heat death, the cosmos will be a place of absolute stillness. No stars will shine, no planets will orbit, and no life will exist. It will be a universe in which entropy has reached its maximum, and all processes have ceased. This fate is called the heat death of the universe. It represents the ultimate end of all things, a point where the cosmos has expended all its energy and reached a state of perfect equilibrium. It sounds like science fiction, a scenario straight out of a dystopian novel or a futuristic movie. The idea of a universe devoid of light, heat, and life is both fascinating and terrifying. But this is what physics predicts billions of years from now. Based on our current understanding of the laws of physics, particularly the second law of thermodynamics, this is the most likely outcome for the distant future of the universe. The heat death theory is based on the second law of thermodynamics, which states that entropy or disorder always increases. This fundamental principle of physics dictates that energy will always spread out and become more evenly distributed over time. As the universe expands, it becomes more disordered, leading to a state where no usable energy remains. The galaxies, stars, and planets that we see today will become increasingly isolated and cold. Over time, galaxies will drift apart, stars will exhaust their fuel, and black holes will evaporate through Hawking radiation. The universe will continue to expand, and the distances between celestial objects will grow ever larger. This process will take an unfathomable amount of time, far beyond the current age of the universe. We are talking about timescales that stretch into the trillions of years, a duration so vast that it is almost impossible to comprehend. Eventually, the universe will reach a state of maximum entropy, where no thermodynamic free energy is available to do work. In this final state, all processes will have ceased, and the universe will be in a state of perfect equilibrium. This ultimate fate, where the universe is cold, dark, and lifeless, is what scientists refer to as the heat death. It is the end of all things, a point where the cosmos has reached its final, unchanging state. Could this endless expansion slow or stop? The universe, as we know it, is constantly expanding, driven by mysterious forces that we are only beginning to understand. This expansion raises profound questions about the ultimate fate of everything we see around us. Will the cosmos continue to stretch out indefinitely, or could there be a dramatic reversal in its future? Some scientists believe dark energy might fade or even reverse. Dark energy, the enigmatic force accelerating the universe's expansion, could potentially change its behavior over time. If dark energy were to diminish or switch to a force of attraction, it could alter the destiny of the cosmos in ways we can scarcely imagine. Maybe the universe could collapse in a big crunch. This scenario envisions a future where the expansion halts and reverses, causing galaxies to rush back together, ultimately leading to a colossal implosion. The Big Crunch would be a dramatic end, compressing all matter and energy into a singular point, much like the conditions believed to have existed at the universe's birth. But so far, all evidence says expansion is winning. Observations of distant supernovae and the cosmic microwave background radiation suggest that the universe's expansion is not slowing down. Instead, it appears to be accelerating, driven by the persistent push of dark energy. If it keeps going, it never ends. The Big Freeze theory suggests that the universe will continue to expand, cooling and spreading out until stars burn out and galaxies drift apart. In this cold, dark future, the cosmos would become a vast, empty expanse, with only the faint glow of dying stars and the remnants of once vibrant galaxies. The Big Freeze theory suggests the universe will continue to expand, cooling and spreading out until stars burn out and galaxies drift apart. Over trillions of years, the universe would become a cold, dark, and desolate place, with black holes slowly evaporating and even the most stable particles decaying. In contrast, the Big Crunch theory posits that gravitational forces could eventually overcome expansion, pulling everything back into a singular point. This would be a cataclysmic event, reversing the expansion and causing galaxies, stars, and planets to collide and merge, ultimately leading to a final, fiery collapse. Evidence for the Big Freeze includes observations of the accelerating expansion of the universe, driven by dark energy. These observations suggest that the universe's expansion is not only continuing but speeding up, making the Big Freeze a more likely scenario based on current data. However, some argue that dark energy's nature is still not fully understood, leaving room for the possibility of a Big Crunch. The true nature of dark energy remains one of the biggest mysteries in cosmology. If its properties were to change, it could potentially lead to a future where the universe's expansion halts and reverses. As our understanding of the cosmos deepens, the fate of the universe remains one of the most profound questions in science. Whether we are headed for a big freeze, a big crunch, or some other unknown fate, the quest to understand the ultimate destiny of the universe continues to drive scientific inquiry and exploration. Imagine yourself slowly dissolving, your atoms drifting alone through endless cold, a final echo of a universe that once burned bright with life. No light, no heat, no way back, just the fading whisper of everything that ever was. As we reflect on this dissolution, we ponder the nature of existence. What does it mean for matter to dissolve, for the universe to expand forever? In this vast expanse, we find both an end and a beginning, a reminder of our fleeting presence and the eternal dance of the cosmos. The universe might not end with a bang, but with silence. Still, these questions remind us, we're part of something vast, mysterious, and beautiful. And as long as we're here, we can wonder. Imagine the countless stars, each with its own story. The universe is not just expanding, it's evolving. From the Big Bang to the present, every moment is a chapter in the grand cosmic story. And as we gaze into the night sky, we are reminded of our place in this magnificent universe. What's your wildest theory? Could the universe collapse or start fresh, or maybe something entirely unexpected? Comment below. Your idea might inspire our next video. We love hearing your thoughts and theories. Subscribe for more mind-bending questions, and stay curious. Hit the bell icon to never miss an update. We have some exciting content coming up that you won't want to miss. Stay curious, and see you in the next video.